Okay, Algebra 1 students, here is a short little video introducing the sets of the number system that, that I feel are important for you to know about, okay? We don't spend a ton of time on this, and it's not really tested, but the information and the properties of numbers that you're going to learn to work with depend upon your understanding of these sets. Now, there's more than one way that people represent these sets of numbers. I choose this way, which I learned from learning how to teach my senior class, MRWC, and it makes a lot of sense and flows nicely. So let's begin. The center is the smallest set of numbers. They are called the natural numbers or counting numbers. They are positive whole numbers and they begin with 1, all right? And they go on into infinity. The next set of numbers that is layered on top of the natural numbers, and I'm going to talk about that in a minute, are the integers, okay? Integers are positive and negative whole numbers, and they include 0, okay? So all of the natural numbers are also in the set of integers, but it doesn't work both ways. Not all integers are natural numbers, okay? All natural numbers are integers. Every every set of numbers that is inside another set belongs to the set that they're in and the set that's above them, okay? So natural numbers are the integers. They're all the positive integers that begin with 1. But the integers contain numbers is in this space that's surrounding natural numbers. The integers contain numbers that aren't in this box, okay? So that means 0 and all of the negative integers would be in this shell surrounding the natural numbers. All right, so let's keep moving and let's move to the shell that's on the outside of the integers. These are rational numbers. Rational numbers are literally a ratio of 2 integers, okay? Literally 1 divided by 4. 5 divided by 8. Here are 2 of them right here. All of those numbers are integers and they're expressed in ratios or division problems. They can be expressed as repeating decimals like this 0.333 ... That means it goes on forever. That happens to be 1/3. Or they can also be terminating decimals, which means they're decimals that have an end. And I'm talking about decimals like 0.5, which stands for 1/2. Okay? The next box I choose to call the real numbers, and I got that designation from the MRWC people. The irrational numbers really don't have their own set, okay? They are considered real numbers because they do fit onto the number line. But as we are going to soon learn, They don't have anything to do with the rational numbers, okay? As I told you before, the natural numbers and the integers and the rational numbers are all part of the set of real numbers. But what is contained in this shell, in this space that's surrounding these numbers in the middle, are all of the different types of irrational numbers. An irrational number is a number that cannot be expressed as the ratio of two integers. And like I said, we're going to learn about that very soon. But some of the irrational numbers that are in this set are logarithms, numbers such as pi and e, which you learn about in Algebra 2, and any square root that is not a perfect square, which we do learn about in Algebra 1. And that includes numbers like the square root of 2, the square root of 6, etc. A perfect square, like the square root of 4, which equals 2, and the square root of 16, which equals 4, those are actually natural numbers, okay? They are all positive whole numbers, all right? So they're natural numbers. Now, the other thing I want you to know about real numbers before we finish this out is that real numbers can be expressed as decimals, but they are non-repeating, never-ending, okay? And we'll talk more about that a little later. Last but not least are the complex numbers. And you can see that all of the real numbers are actually part of the complex number system, all right? We don't learn about these numbers in Algebra 1, really. We touch on them in the context of solving some quadratic equations in the second semester. But basically, complex numbers are not on the real number line. You cannot locate them on the x-axis of our coordinate plane. All of these other numbers you can locate on the number line, but you cannot locate a complex number, okay? Complex numbers contain a part that is the square root of a negative number, okay? And we'll talk more about that next semester. Pardon me. So, like I was saying when I got interrupted by a sneeze, these complex numbers are nothing that we go into great detail about, but I want you as Algebra 1 students to have all the information possible that could help you understand what's going on in algebra, okay? And these numbers exist, and you do have to work with them next year in Algebra 2. So, thank you for listening to this. I hope this helps you fill out your chart. And like I said, we will be talking more about these numbers sooner than later. Thanks for listening, and I'll see you in the next video.